Welcome to VMware Vdefend security for VCF 5.x. This is the VMware Vdefend Firewall Architecture module. I am Chris McCain. I'm a director at VMware by Broadcom, and I work specifically in the Application Networking and Security division. In this first module, we are going to look at the architecture of Vdefend as well as common use cases for the VMware Vdefend security solution portfolio. A little bit about Vdefend to start with. VMware Vdefend delivers a software-defined firewall and is part of the components that make up the communication infrastructure for the software-defined data center. More specifically, Vdefend is the component that protects and/or controls the way traffic flows through a software-defined data center. Vdefend is made up of a management plane, a control plane, and a data plane, and we'll get into more details of those. The data plane, of course, running in the hypervisor being one of the components that comes in the VMware Cloud Foundation private cloud stack, which also includes SDDC Manager, vSAN, your vCenter, vSphere, Tanzu, and the ARIA suite for both operations and automation. The benefits of Vdefend, well, VMware Vdefend provides the following advantage as part of the security strategy in VMware vCloud Foundation. We offer gateway firewall, distributed firewall, URL filtering, IDS, IPS, NTA, NDR, malware prevention. Vdefend protects applications with built-in security features, including the aforementioned hypervisor-based distributed firewall and the threat prevention services. One of the best benefits of the Vdefend architecture is that it scales linearly in the data center. Because of its architecture, because it runs in the hypervisor, as you add a new host into your data center, you are not just adding more CPU and more memory, you are also adding all of these abstracted security services. Therefore, Vdefend scales very well inside the data center. Vdefend provides centralized policy management, and Vdefend is a complement and/or improves upon any existing security solutions you have. So as you go through this course, think of Vdefend as an opportunity to build stronger security posture across your organization due to its uniqueness of architecture and features. But it is not an and/or proposition with some of the traditional security tools that you might already be using. The management and control planes in Vdefend, these planes are part of a single management cluster. They're combined together. The management plane provides both the REST API and the web-based user interface for all of the user configurations to be performed. The control plane is responsible for computing and distributing the network runtime state. So with Vdefend, the control plane is not as critical as when you look at building overlays with the VCF networking components. VMware Cloud Foundation deploys all of the management clusters for Vdefend as part of the management domain. So if you're familiar with VCF, you're familiar with the idea of a management domain and a workload domain. Well, the management/control plane that we're talking about here will be deployed in a VCF management domain, and there will be two of them. And those two separate management and control planes for both the management workload domain and the compute workload domain. So one deployment for the management domain, one deployment for the workload domain, but both of those deployments running inside of the management cluster. This management cluster is formed by a group of 3 manager nodes, giving high availability and scalability. It has a built-in policy manager and controller roles. The management plane includes the policy and manager roles. The central control plane includes the controller role. The desired state is replicated in the distributed persistent database, providing the same configuration view to all of the nodes in this management cluster. And the manager appliance is available in different sizes. If you're doing a lab or proof of concept, maybe the small size. If you have up to 64 hosts in your deployment, then maybe the medium appliance. And then anything larger than that, you would look to use the large appliance size. Just a quick look at a Vdefend firewall kind of for all deployment scenario where we are mixing and matching different architectures, keeping in mind that when you deploy VCF, you may or may not use overlay networkings from the jump. Maybe it's 6 months, 12 months down the road when you have a business case and you start doing overlay networking. But this diagram at a high level shows you that VMware vDefend can be implemented if you're using either VLAN-backed networks or you're using overlay segments, or as this diagram would suggest, maybe you're using a mixture of the two. So you can see the distributed firewall there. You can see the gateway firewall running on tier zeros and tier ones, just kind of showcasing the breadth of the technology in both the virtualized space as well as being able to protect the non-virtualized space. And we'll get into more details of use cases. And then, of course, throughout the rest of the program, you'll get into some really good detail on each of these components and how they get configured and managed to solve these problems. When it comes to visibility, so network security, visibility is often a challenge. Vdefend has some tremendous benefits for visibility and helping to overcome these challenges. But if we're just speaking about the challenges specifically, oftentimes applications on their network and their communication patterns are not something that application owners or infrastructure admins are knowledgeable about. They just don't know how things flow. And maybe it's an old application, maybe the developers are no longer there, maybe it's off the shelf, so they don't know. But just understanding application flows can be a challenge. Understanding if your current firewall rules are correct or effective, especially using traditional model with thousands and thousands of firewall rules. When things become inefficient, having firewall rules or policies that are actually built for things that no longer exist in the network, oftentimes managing those kinds of things at scale is very complicated. What micro-segmentation policies do I need? And this really relates to number one, right? Understanding your flows. So how do I know what policies I need if I don't understand flows? And then finally, if I'm capturing information about my network, how do I know that these communication patterns are normal? What's normal? What's abnormal? Vdefend provides a deep level of visibility into network communications through security intelligence. Security intelligence offers app flow visibility, giving contextual visibility, even going so far as to color code the flows so that you can identify if it's just an open flow or if it's a flow with a rule that's allowing it, or if it's a flow with a rule that's blocking it. So really good visibility and context just by looking at a picture to be able to understand your environment. We'll have an entire module, by the way, on visibility with security intelligence. So we're just kind of introducing and setting the stage here. Security intelligence can eliminate blind spots with comprehensive visibility into flows and the security posture of the organization with full visibility to east-west traffic. And then enhanced context as well, providing visibility to process application visibility with layer 7 context. Security intelligence, we can get analytics information. We've got automation capabilities that we can tie into this. So using Vdefend's inventory and config to detect unprotected flows, workloads, and applications to provide high fidelity rule recommendation. Those rule recommendations can reuse existing groups or services. They can also provide layer 7 recommendations. But the really great part is when we start to rely on AI and ML to determine anomalies within the environment. So behavioral detection of suspicious activity, behavioral detection of threats based on traffic patterns identified by machine learning. So lots of good stuff on that to come. Let's talk about some use cases. Obviously, segmentation, probably the most common thing that people think of when they think of Vdefend or they think of security. How do I control traffic flow in my environment? So Vdefend, purpose-built for segmentation, giving network independent L2 through L7 transparent firewall. Works for virtual machines, works bare metal, works for Kubernetes. Again, giving segmentation all the way through to micro-segmentation for both east-west and north-south traffic. Works on VLANs and overlay back networks, can be applied directly to the VDS DVPG, right? It's enforced at the VNIC level of every virtual machine. That's where we've abstracted security services to. We can include layer 7 app ID, FQDN, outbound filtering to control what websites users have access to. We've got identity firewalling or user-based firewalling, entire module coming up on that later, so stay tuned for that one. And then centralized policy management with decentralized enforcement. Of course, that decentralized enforcement comes in the form of either the hypervisor or a physical box that is running our gateway firewall, or a VM running the gateway firewall, or even an agent running in a bare metal system. So all of the different enforcement methods make up the decentralized enforcement, but it's all run under a single centralized policy manager. Just a traditional example of segmentation. We've got three networks, a VDI VLAN, a web DMZ VLAN, a database VLAN. We've got a core switch routing capability there to get between the different networks. We've got a data center firewall. We got a perimeter edge firewall. But you'll notice that the VDI VLAN's communicating to the database VLAN. There's no security there. There's routing, but there's not a firewall there. There is a firewall between the DMZ and the other networks. But this type of design, which is very common, many customers think they're getting away with, oh, I've got a firewall there to protect DMZ, but it's not giving you the level of security that's required to mitigate against the sophistication of today's attacks. So if we look at the application of Vdefend, boom, you see these little blue circles that pop up, and these blue circles represent the idea that the Vdefend firewall is operating at every single workload running in the hypervisor on the network. So the VMs in the VDI VLAN, there's now firewalling capability, and the database VLAN, there's firewalling capability, and the web VLAN had firewalling capability, but it was only if we traversed outside of that designated set of VLANs, where now even within all of those VLANs, we have security. So what's great about this, you'll notice in the top, is that in order to implement this, there are no network changes that need to be made. You do not have to use overlay networking with VCF's networking components. There are no changes to IP addresses, no changes to the gateways, no changes to your VLANs, and yet we're introducing a layer of security that is unique and very powerful. And what we're really doing here is giving security within a zone. So let's take a little bit more look at this, right? This idea of zoning, this idea of, oh, I've got a perimeter firewall, but I've got these three different zones, and I need to make sure that attackers aren't allowed to move between the zones. So historically, what customers do is they say, well, we'll add firewalls. Now, this is very easy to do in a PowerPoint. It's not so easy to do in the real world because you're injecting physical devices into the network fabric in such a way that you have to force traffic to traverse this network device in order to actually get the inspection that you're looking at. And even so, when you do that, You are now protecting between the zones. So have you deepened your security? Have you improved your security posture? Yes, you have. But there's still a gaping hole within each zone. So what do we do within the zones? Well, this is where Vdefend shines its brightest because we are adding those firewalls to all of the workloads within the zone. We're controlling the traffic within the zone. And it doesn't matter if it's one VLAN, one logical subnet, one logical segment, right? An overlay network, whatever you want to call it. It doesn't matter if it's one of them or hundreds of them. The Vdefend distributed firewall is still providing that security within a zone. And by the way, this is why I said earlier that this can complement existing security that you already have. You might have already built out zones. You might have already taken on that task of putting physical firewalls into the network and it's working. But now you want to close that gap of within the zone. Now you have these two complementary solutions building a strong security posture for the organization. Another way to look at it, here's my prod, my PCI, my non-prod, my services. Now, keep in mind that historically, the only way to separate these things and have security was to put them probably in separate clusters and then stand up your firewalls between those clusters just to create some boundary there. Yeah, you could do it by IPs and you're still going to build your policies by IP, but a lot of times customers were actually taking it beyond just IP and building dedicated clusters with dedicated IP subnets for non-prod, prod, DMZ, whatever it might be. And so here we're looking at a similar example. And then within those zones, we can then leverage Vdefend to create smaller blast radiuses within that zone. So app one has a set of VMs, app two has a set of VMs, but they're both within that prod zone. So where do we really find the time to value for segmentation? Just a couple quick things here. VDI and end user computing, great use case for segmentation. In fact, you could build a very easy one-line policy if the source is VDI and the destination's VDI will block because the VDI desktops may have no reason to talk to each other. So very, very quick time to value. Locking up or monitoring your east-west RDP traffic. We've got much more to come on RDP, but you'll learn by the end of this segment that RDP is one of the most dangerous protocols to leave unprotected in your infrastructure. So very good use case for time to value there. Obsolete operating systems, or let's call them legacy operating systems. This is a phenomenal use case and very easy because of the rich contextual awareness we get by integrating with the hypervisor so deeply. You can build policies to protect operating systems, and we already dynamically understand the operating system. All you got to do is name it. Which operating system are you talking about? And because we communicate with vCenter and vCenter knows that information, it makes it very easy for you. Blocking unsecure protocols. We mentioned RDP a moment ago, but there's others like SSH, SMB v1, very old, very vulnerable protocol, probably not used much anymore, but probably still open and free in the environment. And then protecting other things, the network services like DNS and Active Directory. Very predictable things, very high value targets for attackers, but very easy to protect. So the time to value is very short. VDI or RDSH, using the identity firewall to control access to resources based on user identity. And again, we got an entire module coming up on that. So let's not steal the thunder there. Oh, the gateway firewall. So another use case, different feature of our Vdefend security portfolio, but this is interzone, inter-tenant L4 through L7 firewalling capability, supported on T1s and tier zeros, applied to the gateway uplinks and service links. It could be a VM or bare metal, implemented on an edge node with the ability to do L2 through L7 based policies, layer 7 app ID, URL filtering, TLS decryption, user-based firewalling, and advanced threat prevention. Now, keep in mind that the ATP, the app ID, and the URL filter are only supported on the gateway firewall running on a tier 1 device. So we can get a good idea here from this next slide, just looking at a couple of diagrams. And there's 4 really good use cases for the gateway firewall. So first, distributed security for VMs and gateway security for zoning when you're doing network virtualization. So using overlay networks, building multi-tenancy, trying to separate projects, departments, applications, whatever your tenant boundary might be. But you can see there on the left using the gateway firewall as that tenant firewall, and then having the distributed firewall and all of the additional security services within each tenant that are also protecting the infrastructure. So similar to the model, if you were to be deploying something in a hyperscaler and you're separate from any other customer, you would want your own cloud type firewall to protect. This is exactly what we're doing, or give you the ability to do. We've got distributed security for VMs and gateway security with active stateful and network virtualization, distributed security for virtual machines with network virtualization, and gateway security for physical systems. So you can see on the right-hand diagram, on the left part of the right-hand diagram, stay with me, we've got our hypervisor with some VMs, we've got VLAN A, and then we're running to a tier 1 gateway, and then that gateway also has connectivity to a second VLAN. For that second VLAN, we have bare metal systems that are connected. So this is one of the ways that we can maintain a single policy manager, but impact not just VMs and containers, also physical machines. And then this is, of course, traditional gateway security for zoning or perimeter VLAN-based VMs and physical servers. So 4 common use cases. All right. In-band threat inspection, so advanced threat prevention with Vdefend. We get IDS IPS, looking for known malicious traffic patterns. We get malware analysis to detect and prevent malicious files, leveraging sandboxing. We have network traffic analysis, or NTA, which relies on ML and advanced statistical techniques to determine anomalies. And then we've got network detection and response for aggregation, correlation, and context engines, which are collecting signals from the other 3 to create a threat campaign, to consolidate all this information and provide you a rich set of data to tell you exactly what's happening in the event that there's an attack campaign. The in-band threat inspection, so we can look at gateway IDS IPS. This is detecting and preventing intrusions at the network or zone perimeter. Again, in the diagram here, we've got some tier 1s deployed. The tier 1s are acting as gateway firewalls in between these different environments of the network. The IDPS engine is implemented on the NSX edge in the form of a large, extra large, or bare metal. Supported on the tier 1 gateway, supported for all workloads. It's the same signature set as the distributed IDS IPS, so no difference there. It can be combined with decryption policies, and it's the same or different profiles that can be applied across both DFW and the gateway firewall. So it's nice that as you start to build out the security architecture for building your firewall policy, you can leverage those same constructs, the same tagging taxonomy, et cetera, to be able to build out your IDS IPS security. The signature profiles, so signatures are applied to IPS rules via profiles, single profiles applied to matching traffic. The profile group signatures are based on the criteria of classification type, what severity, what is the deployment or attack target, and what is the affected product. So what does this actually look like? Just a quick glimpse. Here's our interface for managing IDS IPS. You can see in the screenshot there under mode, there's a detect only. This is regardless of the signature action. We will only do alerting. There's no preventative action. And there's also a detect and prevent. This action is per signature, and the action is defined in the profile selected. So you have to choose still alert, drop, or reject. Keep in mind that the mode restricts what actions can be taken when a signature is triggered. So every IDS IPS rule has a mode. Modes can be mixed and matched for different rules. They can be changed. Customers commonly start with detect only, and then after tuning for false positives, we'll change to detect and prevent. And then, of course, don't forget that if you want to block an attack, not only do you have to be in detect and prevent, but your action must be set to drop or reject. And entire modules coming up on IDS IPS as well. So stay tuned. Let's talk ransomware. So here we got a screenshot from our ransomware analysis. We can see in this specific example, this is a case of Jigsaw ransomware. So the screenshot is what you can see in the event that there's a ransomware detected. The reason specifically for this one is because it's a good representation of an advanced malware. And by that, I mean, when this first happened in 2016, when Jigsaw first showed up, it was really one of the first advanced malwares because it was both evasive and polymorphic. Polymorphic meaning that the malware, every time it was replicated or delivered to a new victim, that there was a slight modification to it. Now, in addition to that, the evasive capabilities, the polymorphism made it very difficult. So the program had the capability to learn about the environment it's running on. Now, this could be used, for instance, on an executable for the malware routines. Maybe very specific requirements are set. Maybe they're looking for a language that's set to a specific, maybe it's got to be Ukrainian or it's got to be Russian or whatever, whatever language somebody's attacking. Or maybe the machine has to be part of a specific domain. Or maybe the enterprise is part of a specific industry, right? There's different specificities that could be applied. This can also be used for the malware to try to determine if it's actually running in a sandboxed environment or some type of reverse engineering setup. So it had a way of trying to identify if it had actually been found and then tried to mitigate against the tool that was trying to mitigate against the ransomware. So very clever. And it's doing that to avoid detection by any antivirus or other security tool. So with our sandbox, with Vdefend, it's very different because it's been specifically developed to detect advanced malware, even those that are polymorphic and evasive. And it has a very low level or deep view into the system in which we're executing. So this allows us to understand all the behaviors of the files. Now, keep in mind that the sandbox is only part of the Vdefend ATP solution, but it enables the solution to use the intelligence that we connect or that we collect and analyze it dynamically to inform other areas of the system, like the IDS IPS, to create signatures to detect the malware. Okay, again, more on this to come, just scratching the surface. So the malware detection, network independent detection, prevention of known and unknown malicious files, support for Windows and Linux. We have, pay attention to this, we have a static analysis, which is done locally on the system, and we have a cloud-based dynamic analysis. I'm going to show you here a little flow chart in a minute to show you how this works. Guest introspection is based on file extraction and the blocking for distributed firewall. Because it's in the hypervisor, there is no hairpinning. We've reduced network latency significantly, and there's no need to re-architecture the network to be able to capture this information. The cloud sandbox more on that in a second, enables detection of evasive malwares, even if it hasn't been seen by something on the local host. Now, we can also do some of this at the gateway, the detection of known and unknown malicious files supported on T1s with IDPS-based file extraction, again, static local analysis, as well as the cloud-based dynamic support for file types, documents, executables, archive scripts, and then the cloud sandbox enabling detection of the evasive malware. So just a quick look at the static versus dynamic. Static is good at catching the benign files, things that are okay. It's good at catching obvious malicious files, things with bad signatures, bad file structures, embedded bad code or URLs. And the static analysis also determines if that next step of dynamic analysis is actually required. The dynamic analysis, the files are sent to the Advanced Threat Prevention Service, where it takes a look at the behavior, right? Analyzes the full behavior, does a full system emulation, and looks at full visibility into the subject behavior and the system memory. All right, so check this out. Here's a little flow chart. We get a detection of malware. Looking at the file hash, we will, if it's a known file, that's our local static analysis takes a look to determine if it's benign or malicious. If it's an unknown file, the static file analysis is done locally. The results of the static might show, oh, well, it's benign, oh, it's malicious, or I don't know, never seen this before. So if it's not benign or a malicious or suspicious that we know of, that's when the dynamic file analysis will happen in the cloud, and then we'll get our result back from the dynamic analysis telling us if it's benign or malicious. The in-band threat inspection, so challenges with legacy NTA solutions. So network traffic analysis, another really, really great feature of Vdefend. But the focus is really on security relevancy. Here's what I mean by that. Most NTA solutions out there today are very good at detecting network anomalies. However, that doesn't mean that it's a security issue. So just because you detected a network anomaly does not mean it's something the security team even cares about. So with these types of solutions, essentially a large volume of unstructured data, basically the network traffic information, gets sent to unsupervised machine learning models. Okay. The models are built to look for outliers in the data sets. Now, the problem is that in any network, there's going to be some anomalies at some point. But from a security perspective, we need to focus on the security relevant anomalies, not just any anomaly. So just looking at traffic anomalies doesn't help because we'd be dealing with such a high amount of noise and false positives. At some point, it's like the boy who cried wolf. You're like, all right, well, how many of these things am I going to look at when it's really nothing? The differentiator for Vdefend is that inside of our ATP solution, we implement the unsupervised machine learning to identify anomalies. And then we apply supervised machine learning models based on what we've learned about malware or advanced threat techniques. So that allows us to not only identify the security relevant anomalies, but also to correlate those with other detections with which we might find on the network. More on this to come. So detection of anomalous network behavior everywhere in the network. Remember, this is coming, this analytics information, this collection is coming from the hypervisor. So we're getting all of this east-west information. The machine learning-based detection of traffic anomalies with threat-centric models. It's applied to enrich flow and endpoint security context that's collected by security intelligence. So, you'll start to get the gist here that security intelligence is part of this core group of features that allows us to do really great things with the information that we get from your environment. 14 different detectors, including upload, download, DNS tunneling, DGA, port scans, port profiler, remote services. Every hypervisor is a sensor. I just said that, got a little jump on that one. No need for taps, no need for monitoring the networks, no need for network re-architecture. That's a common theme, right? I think if nothing else, by the time you get out of this module anyway, you're going to know that for Vdefend to operate successfully, I do not need to change anything in the environment. So another way to look at this, right? We've got all these different parts of the MITRE ATT&CK framework where things can go wrong, right? Things like credential access, discovery, lateral movement, command and control, exfiltration, and we can capture all of these different pieces and we can put together total scores across these things to give the SecOps team something to go on. Maybe you've seen this before. Maybe you haven't. Hopefully you haven't, right? Oops, problem with Microsoft PowerPoint. Click OK, and then, files have been encrypted. Don't worry, I haven't deleted anything, but it's all encrypted. If you want it back, you owe me some Bitcoin. So outdated security technologies and processes, too many alerts, false negatives with detection software are listed among the top obstacles. So our in-band threat inspection, our campaign correlation, as we round out this module, enable the analyst to focus on what matters most. So attackers get in, there's command and control traffic, there's lateral movement, more command and control traffic, there's exfiltration, right? All these different attack stages. Having a tool that can map all of these attack stages out for you to show you what's going on in the process, to give you a timeline and a visual map, it really helps. It's a very powerful way to protect and understand the VCF-based private cloud. So how do these things all come together? Well, your threat detection events, things like remote code execution, your malware events like DarkSide, your remote services, your DNS tunneling, anomaly events, malware events, threat detection events come together with NDR. NDR provides this scoring and correlation of these three other features, connecting the attack chain and providing context. This provides security teams with high fidelity by constantly correlating signals from the distributed network sensors that are out there in your hypervisors. The correlation is then put together to form threat campaigns rather than events. So the SOC is not seeing just a disassociated set of events, or saying threat campaigns, and allow them to focus on triaging against a small set of actionable threats rather than what might seem like a random set of just data points. So events collected by the NDR for submission go to the Advanced Threat Prevention Service. This includes IDS, IPS, malware, and network anomaly events collected from intelligence. The Advanced Threat Prevention Service is available in 2 cloud regions, US and EU. And malware events from distributed malware detection are not collected by the NDR at the moment. So we've got all kinds of communication from the distributed firewall through security intelligence to the gateway firewall into our advanced threat prevention services, cloud sandboxes, all building a stronger security posture in that private cloud. Okay, with that, we wrap up this module. Thank you, and we'll see you in the next one.